In today's lesson, 7.3, we are going to discuss multiplying binomials. So as always, let's put your name at the top of your paper to make sure that nobody else gets a hold of it and it's just yours. All right, in the first section, we're going to discuss multiplying binomials using algebra tiles. In elementary school, you worked with some algebra tiles, and we're going to make note of what they were when you were smaller, younger, and what they have become now on the high school level. So in elementary school, you had three big tiles to work with. The first one you had was a big box. The second was a long, skinny stick. And the third was a small baby box. When you were in elementary school, the giant square was worth 100 units of something. The stick was worth 10 units of something, and the baby box was worth 1 unit of something. What we are going to see now that you are in high school is that the meanings of your boxes have shifted a little bit, in that our big box, instead of 100, it is now x squared. Our stick is worth an x, but our baby box still has the same value of 1 unit. Another thing that you saw in elementary school was that if a box was white with nothing in it, then it was worth a positive 1 value. And you saw in elementary school that if you had a box that was shaded, it had a negative 1 value. And that's going to pretty much be the case here also. But that stands for your large x squared, your x, or your individual units. So this will be worth negative whatever, this will be worth positive whatever it is. And this will be a negative of whatever it is. If it is shaded, it will be negative. So things to remember and recognize what they are. All right, so let's go look at problem number 1. We need to draw a frame to work around and to build around. So this is much like a picture frame. We're going to build a frame going down the left and another one across the top, and it makes a small T in the top left corner. There we are. So that's how your frame is always set up in the beginning of any of these problems, every time. So our first binomial has an h, just one h, minus 2 units. So that's what we're going to draw down the left of our framework. So the h is equivalent to a long, skinny stick. And the 2 units will be the 2 baby boxes, but because it is minus 2, we will end up shading them. So 1 long stick for the h. We can label that. And then 2 small baby boxes. 1, 2. And we shade them ever so slightly. -1, -1. All right. Across the top of our frame, let's put in our second binomial. So here I have 3h. So I need 3 long sticks. 1, 2, 3. And then I have plus 5. So I need 5 baby boxes, and they're all positive, so I don't need to shade in anything. All right. So here is my H, 1, 2, 3, 4, 5. From here, we're now going to build the interior of our frame. What we do is you come all the way down to the bottom of our baby box on the left and bring a line straight across from it. You're going to stop where you saw the end of your baby box that was on the top part of the frame. Bring it down. Your goal is to make a nice solid rectangle. So we have one. We're going to fill it in with information from our frame. I saw I had a baby box at the top. Let's bring a line down. And everywhere I see the beginning and end of either a baby box or a stick, I'm bringing a line straight down. You see that? We had 1, 2, 3, 4, 5 baby boxes. I now have 1, 2, 3, 4, 5 very long sticks. Interesting. So let's continue moving across the top of our frame. Hey, here's the beginning and end of another piece of tile. So let's put a long stick through there. Hey, that's a very large box. Great. We'll keep going across our frame to another beginning and end of tile. Excellent. And that discusses everything across the top of my framework. Now let's go across the bottom, the left of my framework. Here's the beginning and end of a tile. So let's draw a line all the way across. And here's another beginning and end of a baby box tile all the way across. All right. So things to look at now that we have some boxes and we need to know if anything is going to be shaded. You remember, because you're smart, that a negative times a positive makes a negative. So this was shaded over here on the left, and this stick is still shaded down here on the bottom. Again, a negative times a positive is a negative. Let's shade some sticks. And again, the third time. And now all of my baby boxes, positive baby boxes times negative baby boxes, makes a lot of negative baby boxes. Great. What does this even mean? I don't know. Yeah, I do. Let's go remember what these boxes mean for us. So it turns out a big X, we remember from our key, a big square is an X squared, a stick is an X, and we're going to count up how many positive sticks we have, how many negative sticks we have, and how many positive baby boxes we have, and how many negative baby boxes we have. So let's count. X squared, X squared, X squared. I have 3 large X squareds. Great. I have, well, let's write that. 3X squareds. Now let's see how many sticks we have. I have 1, 2, 3, 4, 5 positive white sticks. So let's put plus 5x. We know that all of these sticks are positive x's. Let's count how many shaded sticks we have. 1, 2, 3, 4, 5, 6. But they're negative. They're all shaded. So minus 6 x. And finally, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 baby boxes, and they are all shaded, so minus 10. Can we simplify this? Yeah, just a little bit. Let's do it. Those two terms are both simple x's. So what's a positive 5 minus 6? Oh yeah, you know, it's negative 1x. So we end up with a final answer of 3x squared minus an x minus 10. That is the value of multiplying these binomials. Now, if you're like, hang on, you started this problem with h's and now you have x's. What's with that? You're right, I did. It doesn't really matter what variable you have in the problem. If it'll help you, just turn your h's into x's. But if this is a multiple choice problem, that'll be the answer that's correct. You just got to change the letter. And you can handle that. And if you're working this out as an open-ended problem, this will be an acceptable answer. It'll work. All right, your turn. I want you to try setting up and building problem number 2. So pause the video and come and ask me if you get stuck. Welcome back to problem number 3. So in problem number 3, I'm not going to use the tiles anymore. We're going to use the distributive property. And the distributive property is, it has a couple of names. You could say you're doing rainbows, or you could do FOIL. And distribution just means that you are working out a series of multiplication to each term in another set of parentheses. So let's work that out together. So I do this using rainbows, and we can write that as our reminder, rainbows. And yeah, definitely with a smiley, because rainbows are happy. Let's see. B times B. Oh, that's B squared. We know that. B times a positive 1. Well, a positive times a positive, that's a positive. B times 1, that's 1B. Great. Let's do a second set of distribution in this problem. Negative 2 times B. Well, a negative times a positive is a negative 2B. And then our second distribution, negative 2 times a positive 1. A negative times a positive is a negative. 2 times 1 is 2. Great. Now we can simplify by combining like terms. And here they are in the middle again. I hope you'll see that most of the time your like terms are in the middle. So our final answer will be B squared, positive 1 minus 2, negative 1 minus 2. There's my minus 2. And you might ask, hey, do I have to show this 1 here in the middle? No, you don't. It's not wrong if you do, and it's not wrong if you don't. If this is an open-ended question, you can put that 1 there. If this is a multiple choice question, no, they will not have this 1 here. It's just understood that if nothing is showing, then it's a 1. So technically, in a text, in a book, on a worksheet, this is the answer that would be available to you. All right, so let's go look at problem number 4 together to make sure that we have some solid skills growing. I want to make sure that you're really understanding this and getting some learning. So problem number 4, we are going to look at distribution again by way of a slightly different order. You can also be looked at using FOIL if that helps you just to keep straight of did I get all of the distribution done correctly that needed to happen. So FOIL, F-O-I-L, is an acronym. It stands for first, outer, inner, and last. Just to help remind you, hey, did you multiply everything that needed to be multiplied? That's what it's there for. All right, let's see if we can use it. Again, I use my rainbows. So the first two, here's my first, here's my first. First term times first term. So 2t times t will be 2t squared. Outer, so here is my most outer term on the left and my most outer term on the right. Let's multiply those together. A positive times a negative, it's a negative. 2t times 5, 10t. Inner, we've done first, we've done outer. Let's look at the inner. So 7 is in the middle and t is in the middle. Let's multiply these together. A negative times a positive is a negative. 7 times t is 7t. And then finally, last. My last term in my first binomial times my last term in my second binomial. A negative times a negative, ah yeah, that's the positive. And 7 times 5 is 35. Again, we're going to combine like terms, and usually they are here in the middle, side by side. And there they are. So our final answer, 2t squared, negative 10 minus 7 more, negative 17t plus 35. And there it is, folks, your final answer. So it's entirely up to you if you prefer to do the FOIL method or if you just want to do this double distribution property. It is the exact same thing. They are both going to work to get you the exact same answer, and it's just different ways to try and keep the multiplication straight in your brain. That's all it is. So do what works best for you that will be accurate, and always come and ask me in case you get stuck. Let's look at number 5 together. So number 5, this is frequently referred to as the box method. Let's write that. So this is a great visual example for people who want to fill in boxes, who want a picture to work with, but don't want to draw tiles. Tiles can take a while, but this works very nicely. Again, the tiles, we put information on the left and across the top. So on the box, we will also put information on the left and across the top. So my first binomial is x plus 6. X plus 6 down the left. My second binomial is x minus 7. X minus 7 across the top. And now we are going to multiply into the box to fill it in. X times x makes an x squared. Alrighty. X times a positive 6 makes a positive 6x. I'm just drawing these arrows to let you know what two pieces are being multiplied together at any given time. There's that question of, wait a minute, where did they get that from? That's what I'm trying to help you with. The second column, negative 7 times x. Negative 7x. And finally, negative 7 times a positive 6. Negative and a positive is a negative. 6 times 7 is 42. All right. So let's write these down. Now that we have all of our pieces, x squared minus 7x plus 6x minus 42. There are all 4 of my boxes. Let's combine like terms. There they are in the middle. Here they are on the diagonal. This is not a multiplying dividing for combining like terms. That's just an adding and subtracting. We end up with x squared minus 1x minus 42. There you go. Okay, I want you to pause the video and I want you to have a big tackling of problems 6 through 9. Go for it. All right, welcome back. Let's tackle problem number 10 and see if we can knock this out. Number 10, the radius of a circle is 7x plus 3. We need to write an expression to represent the area of the circle in simplified form. Hey, do you remember the area of a circle? Area equals pi r squared. Oh yeah, it's been a while, hasn't it? So let's put the radius of our circle into our equation. So area will equal pi times 7x plus 3 squared. Hey, what does squared mean? What does this squared tell us to do? Oh, that means multiply this quantity times itself. Area equals pi 7x plus 3 times 7x plus 3. At this point, you can make a decision. Do you want to do FOIL, distribution, box method? I'm going to do FOIL. Let's see if we get the same place. Remember, first, outer, inner, last. Oops, I ran out of space, didn't I? Okay, first, 7x times 7x. Ah, that is 49x squared. Outer. A positive times a positive, that's a positive. 7x times 3, 21x. Inner. A positive times a positive, still a positive. 3 times 7x, 21x. And last, a positive times a positive is a positive. 3 times 3 is 9. Great, let's combine like terms. Here they are in the middle. Oh no, what did we forget? there's a symbol pi right here. I need to multiply my entire equation times pi. So we can surround it with parentheses and put it there at the end. So it's not too big of a mistake. We didn't forget too much. 49x squared plus 21 plus 21, 42x's plus 9 times pi. And truthfully, you can leave it just like that. All right, it's your turn. Let's do number 11. Come and talk to me if you need some help.